I'm Liam Gregoire, student code is on the slide if you need it. I'm doing strong mathematical induction. Firstly, weak or simple induction is defined if p of k is true, then p of k plus 1 is also true, whereas strong induction is defined if p of I is true for all I less than or equal to k, then p of k plus 1 is true. When p of k in this case is some arbitrary equation or statement dependent on k. Despite the name, neither method is considered better. Starting with an example from week 6 lectures, we assign the equation p of n with the example. Then follow through to the base case, which shows us p of 1 is equal to 1, which is correct. Followed by the inductive step, which gives us our left-hand side. And then using the initial equation, we use the same variable, k plus 1, which shows us that the equation is correct. Now, to note an example with strong induction, using an example that could not be solved by weak induction. We follow with the base case. E of 2 is equal to 5 times 29 minus 6 times 12, which comes to 73. We then do it again. E of 2 is equal to 5 times 3 squared plus 7 times 2 squared, which also comes to 73, so the base case works. Now we come to the major difference, the inductive hypothesis. So we're going to assume that E of n is equal to 5 times 3 to the n plus 7 times 2 to the n for all n is less than or equal to k. And we get this from the base case working. We can move to the inductive step where E of k plus 1 is equal to 5 of E of k minus 6 of E of k minus 1. We substitute the equation for E of n for the variables of k and k minus 1. And after some algebra, it comes to E of k plus 1 is equal to 5 times 3 of k minus 1 times 5 times 3 minus 6 plus 7 times 2 of k minus 1 times 5 times 2 minus 6. Equating the brackets, we get 9 or 3 squared and 4 or 2 squared, which changes our equation to E of k plus 1 is equal to 5 times 3 of k, 3 to the power of k plus 1 plus 7 times 2 to the power of k plus 1, or the left-hand side. Neatening it up, we make some room so that we can do the second equation, which, as we can see, is the same as the first one, giving us a strong induction for p of n for all n as an element of the natural numbers. So strong induction works like this, by giving examples to prove an equation that relies on numbers occurring before itself, as in how we had with the equation being E of n equaling 5 times e to the e of k minus 1, and so on. Thank you for watching. Here are my resources.